Now we're getting to the culminating event of this section. You've got to be able to figure out word problems with direct and inverse variation. So let's look at this word problem. It says when building a house, the number of days required to build is inversely proportional. That's the same thing as inverse variation. Saying inversely proportional is the same thing. An inverse relationship, it means the same thing. I got this flyaway right here, I'm telling you. And I have a bobby pin. Anyway, it says is inversely proportional to with the number of workers. So I need to pause and I need to think about how I can set that up. This is saying that the number of days D is inversely proportional, so an inverse variation to the number of workers. So I'm going to say number of days is D, and the number of workers I'm going to call W. So our variables are D and W, and I know that it's an inverse relationship. Okay, so D days is the number of days is inversely proportional to the number of workers. So my ordered pair is DW. Now you might go, well, Ms. Sharp, what if Joe over here says WD? You know, that's okay. It's all going to work out. It all works out. So DW. Now it's going to give me a complete set of information. It's wild how that works. It says one house was built in 133 days, and there were 4 workers. And I want to talk real quick about how this is inverse. I haven't really talked about why things are inversely proportional. Direct proportion is as a quantity increases, the other one increases, or as a quantity decreases, the other quantity decreases. With inverse, it's as a quantity increases, the other quantity decreases, or as a quantity decreases, the other quantity increases. I know that's a lot of quantities and a lot of words here, but it's going to take less days with more workers, right? Okay, so that's why this is an inverse proportion. But they told me a complete set of information. It's 133 days with 4 workers. So I had D comma W. I'm being very careful to make sure I understand that the days for worker, the number of days is the D and the number of workers is the W. And I'm putting them all in the right spot. Now it's going to ask a question. How many days? So I don't know D. How many days would it take to build a similar house with 28 workers? So W would be 28. And I'm writing this down as I'm reading it to you on my paper. So let me show you what I just wrote down. So how many days would it take on a similar size house with 28 workers? So this is my complete set of information. This is going to yield my constant of variation. Okay. So my other ordered pair would be, I don't know D, I don't know. And W would be 28. So remember, we use our complete set. And this is inverse. So with inverse relationship, we know that K equals X times Y or D times W. So 133 times 4. And I get that K is 532. My equation is Y equals K over X. So what is my Y in this spot? My Y is W. So W equals K over D. So I'm just, whatever is in the X and Y spot, I'm just interchanging the variables. So W is going to equal 532 over D. That's my equation. Now, I need D when W is 28. And remember me telling you in an earlier example that students really do mess up when the variable's in the denominator, and I recommended that you do cross multiplying. So you get 28D equals 532. I need to do 532 divided by 28, and I get that D is 19. So it would take 19 days if I had 28 workers. It would take 19, oh my goodness, my lid. It would take 19 days. Now this happens to be a Delta math problem, so I want to show you that. Oh my. Hey.